Hello everyone, my name is Bekir Emirhan Demirkale. I'm a freshman in Bilkent University studying electrical and electronical engineering. Today, in this video presentation, I will be walking you through an experiment investigating Hooke's law by measuring spring constants for two different springs. Before I start showing the steps of the experiment, I want to provide some background information and the main theory and equations we will be using in this experiment. Hooke's law states that the force needed to stretch or compress a spring is directly proportional to its displacement from the equilibrium position. Mathematically, it's expressed as F equals minus K times X, where F is the applied force to the spring, K is a spring constant, and X is the displacement from the equilibrium position. By conducting this experiment, we aim to calculate K for two springs and confirm the proportional relationship between F and X. In this experiment, we will be utilizing two types of springs, weights ranging from 50 grams to 200 grams, a ruler for precise measurement, a stand and clamps for stability, and a calculator for data analysis. Now I will be explaining you the step-by-step procedure of this experiment while simultaneously showing me and my lab partners conducting the experiment. At the very beginning of our experiment, we secured a stand on a level surface and attached the spring to ensure free movement. The equilibrium position, or the spring's initial unstretched length, was measured. We added weights to the spring one at a time, starting with 50 grams and incrementally increasing it by 50 grams. For each weight, we recorded the stretch length and calculated the displacement. Using the formula F equals m times g, with g as 9.8, we determined the applied force. We repeated these steps for weights of 100 grams, 150 grams, and 200 grams for each spring. Finally, we calculated the spring constant K for each displacement and summarized our data in a table. In this table, we wrote down our measurements and calculated the value for each spring for every value. We calculated the uncertainty percent by seeing how much the value of K differed from the average value of K. We can see that while the uncertainty was quite low and consistent for spring 1, for spring 2 the value fluctuated quite a lot. The reasons for this uncertainty may be imperfection in the spring that was used, measurement equipment not being precise enough, and basic human error. Here you can see a graph containing the data of displacement and force applied and the best line for each spring. According to Hooke's law, the slope of these lines of each spring is equal to the value of K, which is the spring constant. From our graphs, we observed a linear relationship between the applied force and the displacement for both springs. This supports Hooke's law. Additionally, the different slopes highlight variations in stiffness for each spring. In conclusion, the experiment successfully demonstrated that the force applied to a spring is directly proportional to its displacement, verifying Hooke's law. However, potential errors such as slight inaccuracies in measurement or spring imperfections could impact the results. Thank you for your attention to my experiment. I hope this presentation gave you a clear understanding of Hooke's law and its applications.